Hi everyone, this is Jitra and welcome to this 5-part series of building a scalable multilingual customer support solution using AWS. Whether you're a developer looking to implement language support for your application or an architect designing enterprise solution, this series will give you the tools and the knowledge you need. Let's start by understanding the key challenges companies face with multilingual customer support. First is the language model management. Imagine running separate AI models for each language you support. Not only does this increase your infrastructure costs, but it also creates a maintenance nightmare. Every update needs to be replicated across multiple models, and ensuring consistency becomes really difficult. Second is infrastructure costs. Traditional approaches often require deploying separate models for each language and support domain. Just imagine, for a company supporting just 3 languages and 3 support domains, they would need 9 different models to maintain and run. The costs add up very quickly, especially when you need high performance hardware for each model. Third is scaling complexity. As your customer base grows and you add more languages, scaling becomes exponentially complex. You're not just scaling one system, you're scaling multiple systems, each with its own requirements and bottlenecks. In this series, we'll build a solution that elegantly addresses these challenges. Here's what we'll create. Going through our architecture first, at its core, we'll have a base language model with general understanding capabilities. But instead of creating separate models for each language, we'll use something called LoRA adapters. Think of LoRA adapters like universal translators. Instead of learning every language from scratch, our base model learns how to understand and communicate. And the LoRA adapters fine-tune this knowledge for specific languages and domains. The impact on resources is dramatic. Instead of terabytes of model data for each language, we are looking at just megabytes for each adapter. Okay, now coming back to what our system will support. We're going to work on multiple languages, but initially we'll just use Spanish, Russian, and French. We've chosen these 3 languages because they represent different families and writing systems, which will demonstrate the flexibility of our approach. The same principles that we'll discuss can be applied to any language combination and business needs. Next, we're going to build a system that will support 3 specialized domains for now. One is product, another is technical, and the third is billing support. Each domain requires different vocabulary and context understanding. Technical support needs to understand technical terms and troubleshooting steps. Billing support needs to handle numbers and account queries. And product support needs to understand product specifications and features. Before we dive into the implementation, let me show you how our final system will look like. I'm opening a terminal and first installing all our requirements. Once the requirements have been installed, now I'll run the SageMaker setup file to create our model and the endpoint configurations. Okay, now that we have successfully set up our model endpoints and the model configuration, let us look at our results and see in live how our project works. When we send test queries in different languages, we can see how our system handles real-world customer support scenarios. Let us look at what responses our model has generated. For the first Spanish query, our system has correctly identified that the language is Spanish, and it has also identified that this is a technical support query. It generated a response in Spanish addressing the product issues, even though most of the instructions are in English. Then we can see that for our French query, the system has switched correctly to the French adapter, and it has maintained the technical support context. It has generated a response about account access issues in French. Now look at this query. The system mistakenly detected this language as Spanish instead of French. This shows why in production we would need a more sophisticated language detection system. Looking at this query, the system has correctly identified the language as Russian, but the response isn't fully in Russian, suggesting that a Russian and the Spanish adapter might need more training data or fine-tuning. We can see lots of areas for improvement, but the great thing about our LoRA setup is that we can improve these responses by training better adapters without changing the base model or the deployment infrastructure. We could enhance the language detection, we could improve the domain-specific responses, or add more language adapters, all without changing the base model. In the next video, we'll set up our development environment and start building the foundation for our system. We'll cover everything from configuring AWS services to implementing our first LoRA adapter. If you want to follow along, you can find all the code and the resources in the GitHub repository linked in the description below. Don't forget to subscribe to catch the next video in this series to start with the actual implementation. And if you have any questions about the architecture we discussed today, feel free to drop them in the comments below and I'll answer them for you. Thank you.